We talked yesterday, ready, about graphing with intercepts, okay? And all of the answers that you had were just random points on a graph that had no meaning, right? They meant nothing to you. If you had to plot 0.08, you plotted 0.08 and it didn't mean a thing to you, okay? So anytime we talk about application problems, it means let's put like a kind of a story along with it. So here's what we're going to talk about. You had the Seats Honor Society inductions last month or whatever, right? So when Miss Krupe and Miss Budziak plan for that, they have people RSVP. Okay, everybody listening? Calculators down. So they got 180 RSVPs that said, yes, I'll be there. So they didn't want to use the cafeteria, so they said, let's rent some tables. Let's rent some nice round tables, okay? It'll class it up a little bit. The tables come in two different sizes. Small tables can seat 4, and large tables can seat 6. But they were having a little bit of a debate. So Miss Budziak said, I want small tables, all small tables. I don't want any large tables, too big. Too many people will be talking if there's too many large tables, right? So 4 to a table and no more. Miss Krupe said, well, what about families who have big families? We got to have 6. I want all large tables and no small. See where I'm going with this? It's intercepts, right? So do you realize that an intercept means when 0 is in one of those two spots, it means all of something and none of the other, right? So today we're going to interpret what those intercepts mean. So let's take a look at this. First of all, we're talking about standard form. And standard form is AX plus BY equals C. Agreed? So the only difference from today and yesterday is that yesterday I came out and I gave you an equation. I said 3x plus 2y equals 12. Find the intercepts. You have got to create that equation yourself today. And we're going to use this information up here. So small seat 4, large seat 6. You have to assign your variables. So I'm going to say, well, X or 4 was just mentioned first, so let's just make small the X and let's make the large the Y. And when I add those two combinations together, I need to be able to seat 180 people. Okay, with me? So what would my equation look like over here? Just take a stab at it. Yeah, Jacob.
4x plus 6y.
Yep. So if I were to take the number of small tables and put it here and multiply it by 4, and the number of large here, which is times 6, this is going to be my equation that if Miss Krupe and Miss Budziak sat down and used some equation to help them figure out how many tables they need to order, this would be the equation they would use, okay? The next thing I need you to know and do 100% of the time for a word problem is this. This basically says, now that you know what you assigned X and Y to, I want you to write that right here in your ordered pair because this is going to be a lifesaver. You'll see why. We're going to refer back to that often. Okay? So my X value represents the small tables and my Y represents large. All right, I got that up here. Let's move on. Okay? So let's pretend like Miss Budziak got her way. Let's pretend like she got her way. She got all small tables. No large tables were ordered. How many small tables would they need to order? And in order to figure that out, wouldn't you just say, so she wants no large tables, right? All small. So if she doesn't want any large, then make the Y equal to what? 0. And solve for X. So let's not forget about, sometimes I do the whole, just go ahead, cover it up. Well, sometimes we forget then what that means. So like that means 4x plus 6 times 0, because we're not getting any of those. And again, remember I showed you could skip that. So that results in an equation that says 4x equals 180. And when I divide by 4, I figure out that x is equal to 45. But you are writing it, you can scooch up a little if you need to. You are writing that as 45, comma, 0. Agreed? Okay, everybody agreed? So I have 45 small tables when I don't order any large. Well, let's just say that Miss Croupy says, well, I just have this argument and here's why we need large tables. I don't want any small tables. All large. So then what should I do for the x? Make the x equal to 0. And then solve that equation. So 4 times 0 plus 6y equals 180. It's the same process as I used yesterday. And for those of you who weren't here, basically it was just to find the other axis intercept, make the other variable 0, because that's the axis it's on. You'll see it when you watch the notes. So 6y is equal to 180. I'm going to divide by 6, and y is going to equal 30, which means when x is 0, y is 30. Okay. So I haven't done anything crazy yet. You're with me. Probably. You're still following me. This is where it becomes an application problem, really. I'm going to ask you to interpret, and with a sentence, in words, with capitals and periods, explain to me what the intercepts represent. So, what does the intercept 45-0 represent to you? Anybody have a way they want to formulate it or say? It represents what, James?
Only small tables in the
Yeah, in the cafeteria. Only small tables. I need 45 of them. If I need to sit 108 people and I don't want any large, I'm going to get all small. This means I'm not ordering any small, but I need to order 30 large. And you understand why you need more small than large, right? Because less people fit at it. Good. Okay? All right. So I'm going to take this information and graph it on my intercepts. But before you connect it, you're going to want to listen to this. So I'm going to graph 45-0, and I already have it written here for you. This is x, which is small, large, which is y. And then I have 30 for my... Now, if you are like one of those sloppy hand drawers, this isn't going to work for you. You're going to want to get, not right this minute, either an edge of your book or a ruler, and you're going to want to connect these points really, really perfectly. You're going to see why in a minute. Because Miss Munoz walks in while they're having this conversation about what kind of tables to order, and they can't agree and they're arguing, and Miss Munoz says, fine, just order some of each. Order some small and some large. Do you see the math now that we have to do? Well, if small fit 4 and large fit 6, how do I figure out some combinations that don't make me order too many tables, but I got to order enough? So, hint, use the graph. What do you mean use the graph? Look a little closer. Do you see anything on this graph that could be of use to you? How about, well, this is why actually the other one worked way better. If I had done my line better, that should be exactly right here, connected. Okay, 1 second. This should be exactly connected. So what I'm looking for on my graph is where the 2 points meet at where the grid lines intersect. I don't want to know, first of all, I can't have 11.5 tables. Okay? So I'm looking at these 2 points. Yes, Chloe? That, yes. And that, yeah, you could look at that. 25, 15. That one, I don't think that one would work. Well, you know what? If you want to check it to see if that would work, how could you? You would just plug those in for x and y and see if it equals 180. I'll show you what I'm talking about. So let's take a look at this point right here. This is 30, 10, and this is 15, 20. Okay? So I have 15 small and 20 large, or 30 small and 10 large. And how do I know, other than the graph, because my graph was a little off. Graphs are always subjective. If you want to really know if you did it right, what do you do with these points? You plug them back in up here. So what's 40 times 30?
1,200.
It's almost, yes. 1 extra 0 there. What is 6 times 10? What's 120 plus 160. It checks. So if you give me, and I want you to underline these words, possible combinations. When I ask you for that, that's what I'm looking for. I'm looking for you to say, oh, what other values of X and Y would work when I plug them in, okay? So are we good so far on this example? This was the standard form example. Do you have any questions about it? Okay, because now I want you to flip that over, and we're going to take a look at, this one's not too bad, the slope-intercept form example. Meaning, look here guys, remember this is like the carpet example, right? I am confident that almost every single one of you are masters at writing an equation in slope-intercept form. If I said to you, hey, this carpet guy, he charges $50 to come to your house, and then $30 for every room, I have no doubt that you all would do this. Right? Because it's $30 per room, $50 to come, and there you go. Okay? So let's listen to this example. Let's say you have a submarine that's underwater, that's where they belong, right? And it is designed to explore on the ocean floor. And right now it's on an expedition 13,000 feet below sea level. So you learned in geography, because Mr. Grail's an awesome geography teacher, right, last year, that sea level is 0, okay? So negative 13 means below. And here, I want you to underline this word. Does everybody know what that word means, ascend? Here's kind of the deal with this. When you take some tests that have a lot of words in them, sometimes they're testing your English abilities better than your math abilities, right? Because the kid could totally know how to do the math in this problem, but if they didn't know what ascend means, they're kind of like, well, wait a second. But they give you context clue. What can we infer? If it's ascending to the surface and it's underwater, ascend means that you're going up. I know Miss Kirby teaches you context clues, right? Okay, and it's ascending at a rate of 650 every minute. So it's down at the floor of this ocean, getting closer. So the first thing I want you to do, which I know you can, is write the equation that represents that situation. Except, I mean, you could just say y equals, and here's the deal. We got some people who kind of are half and half on this. Some people say, I don't care. I like to have where they're starting first, and they are ascending next. And then there are people who are like, I can't do it. I have to have my x first. You know what I'm talking about? Then those people would write y equals 650x, and it started 13,000 feet below. You can do it whichever way you want, guys. Just understand it, right? But what I'm asking you to do is let E represent the elevation, which is your dependent. And the M is minutes. So what I want you to write is your elevation is equal to, and I'm going to go with the way I prefer, per minute, and I'm starting 13,000 feet below. And as soon as I have that in my independent variable represented, one second, Daniel, I am going to write this. I just want to get through this. So this is going to be what it, and here's why this might be helpful. Because you know that normally it's y equals. What is E? It's in the y spot. So this is elevation. And my first spot is going to be minutes. Got it? Okay, so right now, I'm just going to ask you to find, I'm not asking you any fancy stuff, find the X and Y intercepts. What's your question, bud?
Is that supposed to be 13,000, 16,000, or 18,000?
13,000, yep, 13,000 because it's right there in the problem. So when M is minutes and that equals 0, let's write our equation here so we can see it. And I put a 0 right there. That's kind of easy because that's going to be E is equal to 650 times 0, which is 0. And so what's my E intercept? As funny as that sounds. My E intercept is negative 13,000, which means what is my ordered pair?
Please excuse the swim team at this time. Thank you.
E is this, and that's 0. So you guys go ahead and then literally just for, what are we doing? The word problems at the end. You'll see them in the book, okay? So we have this here. Is everybody good with that? Now you got to find the M intercept, as funny as that sounds. So make E equal to 0 and solve for M. It's not that bad. Good luck, guys. So you're going to add 13,000 to both sides, which is going to give you 13,000. And then you're going to divide. You guys should do this stuff in your sleep, right? And you're going to get 20 is equal to M, which then means I got to know, is that 20 comma 0 or 0 comma 20? Well, what's M? Oh, it's minutes. Man, that is saving me. So I'm going to put the 20 here and the 0 there. And now, are you ready for it? What do those, no, before you even graph it, what do those intercepts mean? What are they standing for? What do they represent? I know you know what this one represents. That 0 minutes, meaning they're still on the ocean floor. They haven't started going up yet. They're still 13,000 feet below. But what does that mean? Shane?
In 20 minutes they get back to sea.
Yes, because he looked at the 0 in the elevation spot, which means, you ever see a submarine come up from underwater? Like, it has this buoyancy to it and it just kind of pops up. That means when the elevation of that